Hello everybody, this is Lamanda Lucy, and today I would like to speak about control loops. Also, we will discuss the control loop types, so if you have any question, please feel free to contact me.
Control loops. Control techniques have evolved from a crude art to a sophisticated science. Originally, the control function was performed manually by operator. The operator typically used the senses of sight, feel, smell, and sound to measure the process. The operator would adjust a device, such as a manual valve, or change a feed, such as adding a shovelful of coal, to maintain the process within set limits. The quality of control was poor compared to today's standards and relied heavily on the capabilities, response, and experience of the operator. In modern systems, the operator's control function has been replaced by a control function that continuously compares a measured variable, the feedback, with a set point and automatically produced an output to maintain the process within limits. This control function is the controller. The operator acts as a supervisor to this controller by setting its set point, which the controller then works at maintaining. This automatic control function provides consistent quality producer, pollution reduction, labor savings, optimized inventory and production, quality products, increased safety, and control of processes that could not be operated manually. Control modes. The two basic modes of control are on-off and modulating. In either case, the physical and chemical values that are the object of measurement are generally referred to as variables. On-off control. On-off control is also known as discrete control or two-position control. In it, the output of the controller changes from one fixed condition to another fixed condition. Control adjustments are made to the set point and the differential gap. The differential gap has basically two set points, or one set point with a differential gap or deadband. Modulating control. In modulating control, the feedback controller operates in two steps. First, it computes the error between the controlled variable, the process feedback, and the set point. Then it produces an output signal to the control valve to reduce the measured error to zero. Modulating control. Control loop types. Four main types of control are commonly used: feedback, cascade, ratio, and feed-forward. Feedback. This is the basic closed, the oldest type of control. It was developed in 1774, when in the first industrial application, James Watt used a flyball governor to control the speed of his steam engine. An open loop has no feedback and cannot be considered as a closed loop. Remember that the operator, monitoring the controlled variable and adjusting the output to the valve, acts as a controller, thereby closing the loop. However, this is not an automatic function, and it totally depends on the operator's manual output as an input to the loop. Cascade. In cascade control, the primary variable is controlled by the primary controller, sometimes known as the master. However, it is not a direct control. Instead, it manipulates the set point of the secondary controller, which controls the secondary variable. Ratio. In ratio control, the controlled variable follows in proportion to a second variable known as the wild variable. The proportionality constant is the ratio. Ratio systems are not limited to two components. One wild flow can adjust several controlled flows. Feed-forward. A feed-forward control system measures a disturbance, predicts its effect on the process, and immediately applies corrective action. Feed-forward control is by itself insufficient. It is generally used in conjunction with feedback control to trim the feed-forward model. It should be noted that feed-forward is an open loop. Feed-forward and feedback systems independently adjust the control valve. There is no control applied to the feed-forward variable. It is clear what the loads are in this process: the three ingredient flows entering the vessel. If we measure and sum these three flow rates, then use the total incoming flow signal as a setpoint for the discharge flow controller. The outlet flow should, ideally, match the inlet flow, resulting in a constant liquid level. Being a purely feed-forward control system, there is no level transmitter, LT, anymore, just flow transmitters measuring the three loads. If all flow transmitter calibrations are perfect, the summing of flow rates flawless, and the flow controller's tuning robust, this level control system should control liquid level in the vessel by proactive effort, thinking ahead, rather than reactive effort, after the fact. Any change in the flow rate of ingredients A, B, and/or C is quickly matched by an equal adjustment to the discharge flow rate. So long as total volumetric flow out of the vessel is held equal to total volumetric flow into the vessel, the liquid level inside the vessel cannot change. If you like this video, please subscribe this channel and press bell icon to get notification of new videos. Thank you so much for watching and have a nice day.